Okay, here we go, ladies and gentlemen. Factoring. I know a lot of you have issues with this, so I thought I'd give it a shot, see if I can help you out a little bit, okay? First thing that you have to understand is what the greatest common factor is. Greatest common factor, also known as GCF, is something that goes into all your terms. A trinomial has 3 terms, a binomial has 2 terms. What we're going to look at is a binomial here and see if you can take out a greatest common factor and write down what is left inside. Okay, so first of all, you have to identify what that GCF is, and in this case, you'll see that it's hopefully 3x. I suggest looking at the numbers first. 3 and 6 have a greatest common factor of 3. X squared and x have a greatest common factor of x. In order to find out what's left on the inside, what we normally do is a division, right? You're taking out a GCF, so you divide it. And what's left is x minus 2. Okay, and this is your factored form. Give this one a shot here. See if you can look at the number and then the variables. Hopefully you'll see that your GCF is, again, 3x. Now we also have a y, okay? And then that means that your factored form would be, now we divide by 3xy, you divide by 3xy, left with 5y minus 3x. And that is your factored form, okay? That's what we call GCF factoring. Now, what we're going to be looking at next is the ones that a lot of you have difficulty with, and it's trinomials with a leading coefficient of 1. Leading coefficient basically means that you have a 1 in front here, okay? So 1x squared plus bx plus c. These are relatively easy to do, okay? If you understand the whole FOILing process, right? You're undoing this, which means that you're going to break it down into 2 things, right? And if you remember FOIL, right, the first ones multiply to give you that first thing. So it's got to be an x and an x. You have no other choice, right? Now these 2 numbers multiply to give me the last. They give me 12. So the factors of multiply to give me 12 would be 4 times 3, 6 times 2, or 12 times 1. Okay, those are the possible choices that I have here. The other limiting factor is the fact that they add up to give me 7. Because the outside and the inside, right? They add up to give me the 7. So, which of these pairs add to give me 7? Hopefully you see that it's 4 and 3. I need a plus 7, so it's plus 4, plus 3, and you're done. Okay? If we look at the next one here, x squared minus 7x plus, here, let me make get rid of some of these, there we go, minus 7x plus 6, so we'll break it down, x and x, we have the factors of 6, 3 times 2, or 6 times 1, which one of those gives you a negative 7? Minus 6 minus 1, and that, you can always check, right? Minus 6 times minus 1 gives me a positive 6. So that works out well too. Okay, minus 6x minus 1x minus 7x. Bingo. Let's look at another one. This one might confuse you a little bit because we have an added variable. Okay, not a big deal though. Let's do the same thing. Let's break it down. Here we have an x. Let me do another sheet here. Let me get rid of that. So we have x and x. The only difference with this one is that we have a y squared and a y. Kind of, you can see that the x's are disappearing and the y's are appearing. It's kind of symmetrical. Just means that we put a y at the back there. And the choices that we have for multiplying to 8 are 8 and 1 and 4 and 2. I need a negative 6. These are going to give me a negative 6 if they are both negative. Okay? Let's have a look at another one here. This one might make you uncomfortable because it doesn't seem like it's in the right order. If it's not in the right order, then, excuse me there, put it in the right order. Okay, so x squared plus 4x minus 21. And then we're going to go x and 21 times 1, or 7 and 3. Those are the only choices that give me 21. You'll see that 4 can be gotten if you go plus 7 minus 3, and you're done. Okay, these are the easier of the lot, folks. but they still require a little bit of thinking, okay? A couple more here, show you a couple different twists. You'll see that this does not have a leading coefficient of 1, but is there something that you can do? Indeed there is. Okay, what you do is you take out that 5, it ends up being like the ones up above, so 5, and now you have two brackets, x and x. 12 times 1, 6 times 2, 4 times 3 are my choices. Which ones are going to give me 7? Okay, hope you'll see plus 7 will be gotten from plus 4 and plus 3. The 5 out front here is just another term, okay? And you can multiply the 5 onto this one, or you could multiply it onto this one, but you can't do both. It can only be applied to one. Another situation here before we move on to the more difficult ones. This is indeed a coefficient of 1, but it's a negative 1, so we still can factor that negative out, okay? Don't forget that that messes with all your signs. So negative now, x, x, I need to figure out what numbers go in there. I have 6 times 1 or 2 times 3, and this is where you have to kind of guess and check, I guess. Both of these can somehow give me a negative 5, but they need to multiply to give me a negative 6. I have done this a lot, so I can see that it's minus 6 plus 1, right? Minus 6x plus 1x negative 5, and they multiply to give me negative 1. The other choice would have been minus 2 and minus 3, but they multiply to give me a positive 6. So there is a little bit of investigation that you need to do. And the last thing here is that this negative in front, guys, it applies to one or the other of these, not both. Okay? So those are the easier ones. What we have now are a bunch of situations where the leading coefficient is not 1. Okay, that means it starts off with a number in front of the x squared. All right? Now, the first one we're going to look at, you might be able to solve, because hopefully you can see that there is a common factor of 3. So when you reduce it now, you're left with what we had before, and this shouldn't be too bad to do. 2 times 2, 4 times 1 are your choices. That's not going to give you 5, so plus 4 and plus 1. Okay, that's one of them. Now let's try another one. This one does not have that luxury, okay, where you can factor out a common factor. So what you're going to have to do is figure out what's going to work, and there's a bit of trial and error involved. Now, you don't have a lot of choices to give you 2x squared. It has to be 2x and x. Now it could be x and 2x, but there's no other choices, right? Now you can start putting numbers in here. You can put a 4 and a 1, or a 1 and a 4, or a 2 and a 2, and start sorting it out if you want. But there's other methods to do this, okay? And I'm going to show you one way that still involves a little bit of trial and error, but we'll give it a shot anyway, okay? So look, the numbers that multiply to give me 2, 2 and 1. I put them on top of each other. The numbers that multiply to give you that first number, put them on top of each other. Numbers that multiply to give you the last number. Well, you have choices now, right? Let's just pick one. Let's go 4 and 1, okay? So that gives me 2, that gives me 6. We cross multiply now. These are supposed to combine somehow to give me that middle number, and you can see that they can. They can give me either 4, or negative 4, or 8, or negative 8. So what we do is we switch these. We try something else over here. Let's just go 1 and 4. And if that doesn't work, we'll put something else there, 2 and 2, right? Let's give this a shot. 8 and 1. I can get a positive 7 out of 8 and 1 if it's a plus 8 and a minus 1. That minus came from here, so we make that second one negative, and then there are your binomials. So we'll go 2x minus 1 and 1x plus 4, right? Let's have a look at another one here. This one is a little trickier again. It's got a bunch of stuff there. Hopefully you can see you can take out something first, right? There goes the bell. So minus 2x, let's take that out. You're left with 4x squared minus 5x. Threw me off a little bit. Minus 6. Let me just make sure. Plus 10x squared. Okay, good. So now minus 2x Factors of 4. Let's go 2 and 2. Okay. Factors of 6. Let's go 3 and 2. That gives me 6 and 4. I can't get a 5. That's not going to work. How about, no point changing it to 2 and 3 because those are 2. How about 6 and 1? Okay, that gives me 12. That gives me 2. That gives me 10. That's not going to work. So I can't do anything else over here. So it means that the 2 and 2 has to go. Let's get rid of it. Couple minutes, please. Let's go 4 and 1. Let's go 3 and 2. So that gives me 8. That gives me 3. Oh, look, I can get a 5 from 8 and 3. Minus 8 plus 3. The minus comes from here. Boom, there we go. So 1x minus 2, 4x plus 3. Ew! There we go. All right. A couple others here. In this case, I can factor out a negative. You're left with 3x squared plus x minus 4. Let's see what we can put in here. For 3x squared, not any other choice but 3x and x. But let's do it our other way as well, 3 and 1. So now we got 4 times 1 or 2 times 2. Those are the numbers that can go here. I'm going to go 4 and 1 because I can kind of see it. Then that's going to give me a 4. That's going to give me a 3. I can get a 1x if it's plus 4 and minus 3. The minus 3 comes from here. Oops, let me move that up for you. So this is a 1 here. So now 3x plus 4 and 1x minus 1. Okay, last one here, we'll give it a shot. Notice that again, you don't have any other choice but 3x and x. And see if you can figure it out the rest of it before I finish it. Okay, this is one of those ones where you can kind of see. If you need the 13, you know, you set it up this way, you can kind of figure out what's going to work. If you tried the other one, it didn't work, just flip them around and keep trying, right, until you get the right one. Okay, a couple other things we got to show you here. Perfect square trinomials. You don't really need to identify these so much as be able to make them later, but understand that a perfect square trinomial would be something that has 2 equal binomials, which means that you can write it like this. Okay, and if you FOILed it out, you'd see that you have 2 middle terms that are the same thing, and they add to give you the middle number. Okay, now looking at this thing, you can see the first term is a perfect square. The last term is a perfect square. So you check it out to see if it is, right? There are situations where it might not be, but if I wrote down something like this, 2x, if I wrote down 4x squared plus 10x plus 9, well, look, that first one is a perfect square. That second one is a perfect square. So is that equal to that? Well, 2x times 2x, 4x squared, 3 times 3, 9. That gives me 6x. That gives me 6x. I'm looking for a 12x. So no, that's not a perfect square. If this was a 12, boom, that's a perfect square. All right. The one last one I want to show you is this thing called we call it difference of squares. Okay, and this is when you have a situation. If you FOIL this out, you'd see x squared plus 3x minus 9, where these middle terms cancel each other out. So you're just left with the first and the last term. Okay. Now, if you have a situation like this where they're being subtracted, okay, and they're both perfect squares, then that's what we call a difference of squares. This breaks down into x plus 3x minus 3. If I gave you 9x squared minus 16y squared, is that a perfect square or a difference of squares? Well, if this is a perfect square of 3x and that's a perfect square of 4y, then and they've got a minus in the middle, then what we can do is make 1 plus, 1 minus, so that when you do those middle terms, they cancel each other out. Let me just throw one more at you. Let's make another one. How about 16x squared minus 49? Okay? Break that one down. There you go. Does not matter which order they come in, as long as you have them both. Hope that helps, folks. Take care.